Welcome back to Statistics. So, up to now, we've talked about a couple of distinctions that are really important. One of them is the distinction between inferential statistics and descriptive statistics. Another distinction is between a population and a sample. And today I'd like to talk about a third distinction, which goes kind of right along with all those, and that's the distinction between what we call parameters and what we call statistics. So here, I'm using the word statistics in a very specific way. Statistics is, of course, the subject we're studying, but within that subject, the word statistic has a very special meaning. It means something definite, and part of what I want to get across is what that meaning is today. So I've got a couple of slides prepared for that. Let me see if I can get those up real quick. Yes, parameters and statistics. So remember the distinction between the population and the sample. A population consists of all individuals of interest in a particular study, while a sample consists of the usually much smaller set of individuals from whom you can actually collect data. So the distinction between parameters and statistics goes hand in hand with this one. Namely, a parameter is any number that describes the entire population. Um, so, for instance, if you're talking about the population of the U.S., you may be interested in the net worth of individuals in that population. Uh, if I said the average net worth of individuals in the US is around $70,000, then that would be a statement about a parameter because I would be talking about the average of the whole population. On the other hand, a statistic is a number that describes a sample. So if I said, I went out and sampled 100 individuals in the population and their average net worth was $68,000, that $68,000 would be a statistic because it refers only to the sample. Now, parameters and statistics typically come in pairs. You can be talking about the same thing, but if the context is the population, you're talking about a parameter. Whereas if the context is a sample, you're talking about a statistic. So, and there's some special terminology and sort of notation that goes along with this. If we're talking about means, like for instance, average net worth, the mean in a population is denoted by the Greek letter mu, which you see here. Uh, this is that Greek letter mu. If you're talking about the mean in a sample, we use the symbol x with a little bar over it. We call that just x bar for short. And that would refer to the mean in a sample. We also talk about in statistics the idea of standard deviations, and we'll get more into all these concepts pretty shortly. But again, if you're talking about a standard deviation in a population, we'll typically use the letter sigma from the Greek, the lowercase sigma, as the standard deviation in the population. But if we're talking about a sample, we'll use a lowercase s. And so those are some basic notations and ideas from statistics. Let's take a look at the ebook and see what it has to say about this topic. So we're still in Module 1. I've actually skipped a section. We'll come back to section 1.3. I'm in section 1.4, the distinction between parameters and statistics. So pop that open. And as usual, they'll explain the key concepts here, pretty much what I said before, but just more detail. And then they'll go on and give some examples. So let me look at a couple of these examples just real quick. The first one is about free throws. We all know Stephen Curry, the standout basketball player. During the 2015-16 season, his free throw percentage was 90.8. That's pretty amazing. And but suppose you observed Curry's first 10 free throws during a scheduled practice and found that he made 9 out of 10 of those are 90%. What would be the parameters we're talking about here, and what are the statistics? Well, if the population is going to be considered, all of Stephen Curry's free throws during that season, uh, then his season, record there, his what they say, his 90.8%, that's a parameter. But if we think of those 10 free throws that we actually observed as the sample, then that 90% or 9 out of 10 would be a statistic, because it refers only to that sample. Let me just pop open another example real quick, if I can. Get over here. And there was another useful example about voting. Let's take a look at that. They say in a recent election, 52.2% of Americans voted for the Republican candidate. A pollster surveys 100 people and finds out that 55 of them plan to vote for the Republican candidate in the next election. So, what's the parameter and what's the statistic? Well, the population here, when we're talking about an election, would be the set of all people who voted. And so, in this recent election that's discussed, it's a matter of record now that 52.2% of Americans voted for a Republican candidate. So, that 52.2% is a parameter. It refers to the population of all individuals who voted in this election. On the other hand, that 55% who the pollster surveyed and found out that they plan to vote Republican, that would be a statistic, because again, it refers to just um, the individuals in the sample. As usual, there's a bunch of examples, and I urge you to read them all. There's also a glossary of terms at the end, and this will be important in your homework as well as on our first module test. So if you haven't already, dive into that chapter, and there is a homework assignment out there that's waiting for you. As always, if you have questions, let me know. Y'all take care, and I'll talk to you again real soon. Bye now.